Alright, hi class. We have entered our chapter 7, Haloalkane. I hope that you have already done for your video watching for chapter 7, the lectures, and also you have done for the formative assessment. Okay, so Madam have already combined all the questions for non-face-to-face and face-to-face following the hours. Okay, so this is the question for our first hour. First questions, draw and classify the following haloalkane. So for your first structures given here, 2-bromo, 2-methylbutane. Okay, so in your parent chain there's 4 carbon. At carbon number 2 we have 1 bromo group and we have 1 methyl group. Okay, so for this one, if you want to classify the haloalkane, we will focusing at the carbon which contain your halogens group. So in this case, the carbon which bearing with your Br have 3 carbon neighbor. Therefore, the structure for your A is a tertiary haloalkane. So this Rx represent haloalkane. Structures B, we have 3 iodomethyl. Remember, in bracket, this one represents 1 substituents, 3 phenyl heptate. So in our parent, we have 7 carbon. 1, 2, 3, 4, 5, 6, 7. At carbon number 3, we have 1 phenyl group. And then carbon number 3 as well, we have the iodomethyl. Iodomethyl, that means there is 1 carbon, which is your CH2 and iodo. Okay, so to classify this haloalkane, we focus on the carbon that contain or attach to the halogen. So in these questions, the halogen iodine is directly attached to this carbon. Okay, then this carbon only have 1 carbon neighbor. Therefore, it is a primary haloalkane. And for the last structure, 1-chloro-2-isopropyl cyclohexane. So the parent is your cyclohexane. And at carbon number 1, we have chloro. And carbon number 2, we have our isopropyl, which look like this. Okay, so if you want to classify this haloalkane, we're focusing on the carbon that attach directly to the chlorine. Okay, and this carbon has 2 carbon neighbor, and therefore this is a secondary haloalkane. Alright, so for the second question, stamp the following compound based on IUPAC nomenclature. So remember what we have discussed before. First one, you have to find the parents, which is the longest parent chain. Okay, second, we need to put down our numbering so that we can see a lowest possible sets of number. Number 3, identify how many substituents are they. Last but not least, we will arrange following alphabets. Okay, so if you look at the structures over here, so if let's say we starting from the carbon bearing the fluorine as carbon number 1, 2, 3, 4, 5, we can see this is our longest carbon chain. Okay, therefore parent name is called as pentane. Okay, and then carbon number 1, we have the fluorine as our substituents, starting with the alphabet F. And then at carbon number 2 and carbon number 3, we have methyl group. We start with a letter M. Okay, therefore if we follow the alphabet, F comes first before the methyl group. So 1-fluoro, 2,3 dimethyl, because there is 2 groups of methyl group, and then followed by the parent name pentane. Okay, for the part B questions, we have a cyclohexane as the parent. Okay, and then we have 3 substituents. We have Cl, we have ethyl, and then we have methyl group. Chloro start with C, ethyl start with E, and methyl start with M. So following your alphabet, C comes first, and we will turn clockwise. Okay, so for the naming, it becomes 1-chloro, 2-ethyl, 3-methyl, and don't forget the parent name cyclohexane. Okay, so if we want to try to classify both of these compounds, we look at the carbon which contain our fluorine atom. So in the structure for A, this is the carbon bearing a fluorine. Okay, therefore this one is a primary haloalkane. So if we look at the second example for B, the carbon which attach with the chlorine, which have a two carbon neighbor, and we will classify this one as a secondary haloalkane. So do it as a practice for the classification, primary, secondary, or tertiary. Now depends on the carbon that attach with your halogen. Alright, for question number 3, for the following haloalkane, label the nucleophilic and electrophilic site on the molecule. Okay, so if you look at the structures over here, we have our chloro, cyclo, so you practice the naming also lah, chloro, cyclo, pentane. Okay, so at this carbon containing your Cl, okay, the carbon is actually our new electrophilic site, whereas the chlorine is our nucleophilic site. Okay, this is because chlorine is more electronegative than carbon, so chlorine will attract more electron density toward itself. Okay, and it becomes the nucleophilic site, delta negative. Whereas your carbon now is becoming lack of electron, therefore it will become the electrophilic site, lack of electron with a symbol of delta positive. For B, explain why this compound is able to undergo nucleophilic substitution. So if we look at these structures again, and we're focusing on our carbon with a delta positive charge here. Okay, so if we want to attack by a nucleophile will attack at this carbon. Okay, nucleophile will attack at this partially positive carbon. So if let's say I have a nucleophile, which a very easy example, we have an OH minus, and this OH minus will actually attack directly on the carbon bearing the delta positive. Okay, so in sentence, we can say that the carbon-chlorine bond is a polar bond. The carbon bearing the chlorine is susceptible to nucleophilic attack. Okay, it's susceptible, which is also prone to nucleophilic attack. Lagi senang nucleophile nak attack, susceptible.